law of sines to find an angle. You have an angle side-side triangle, and that's ambiguous. So let's look at problem 2C and see if we can remember how we handle this. Now, keep in mind that how many triangles are possible? Could be none. Didn't we have one of those the other day? Yep, could be none, could be one, or could be two. Those are the only possible options, all right? So here we go. Clearly the law of sines. Would everybody recognize that this is a law of sines problem? Because we have this pair that's going to start our proportion. This is our first ratio, sine 36 over 17. And then sine C over 16. So when we cross multiply and divide, or in this case I'm just multiplying the 16 over, I am going to need to second sine, right? In order to find angle C, I am going to second sine that mess right there. One of two things is going to happen. I'm going to get an answer or not when I do that. If it says error, it means there's no triangles possible. It might give me an answer. Second sine 16 sine 36. Close those parentheses divided by 17. Oop, I got an answer. Did you? Did you get 33.6? The ambiguity is that there could be another angle that has that same sign. This number, whatever decimal this is, there are two angles that have that sign. One in quadrant 1 and one in quadrant 2. They are supplements of each other. So, what is the supplement of 33.6? In other words, what's 180 minus 33.6? What is it? 146.4? Now, Chris is sitting there saying, okay, I get this whole idea that when you tell me the sine of an angle is 0.2, that there's two angles that have that sign. One of them is 33 and one of them is 146. That's fact. But Chris is saying, wait a minute, I don't think that's going to work. Why is that not going to work? Two things. First of all, that adds up to more than 180. And second, 17 is bigger than 16, so there's no way the 146 can be across from the 16 if 36 is across from 17. Would you agree with that? So in this problem, this triangle is fine. That angle is fine. But the second possibility isn't possible. So how many triangles are possible? One. Perfect. Peter?
Couldn't like you look at it one way where it's like, if your answer like C is less than angle A, you know for a fact that there could be a second triangle because you know 180
Yes.
is
Yes. But you gotta find the first one first.
Yeah, you still have to like,
Yep.
you don't have to like set up a
Yep.
second triangle.
Yep.
Because you know it has to be great.
Yes, that's absolutely fine. That's absolutely fine. Somehow you gotta come up with one possible triangle.
Yeah.
All right, let's look at the last one. Let's run through it again. You guys are smart. Peter's saying, you know, I don't necessarily have to show all the work you're showing Mrs. Ford. I'm totally fine with that. If you're using your logic to sort through things. How many triangles are possible? All right. Do you see a pair right here? All right, here we go. Sine 35 over 9 equals sine A over 18. Law of sines. let's cross multiply. So sine A is gonna equal 18 sine 35 over 9. Is that okay? And so how will we find angle A? Well, second sine this thing. I heard somebody say I got an error. That's definitely possible, right? I mean, it's always possible to get an error if you don't type it in right. But in these problems, you can be right and get an error, because what does that mean? There's no triangle possible. So the two that we did today, we had none, a 0, and a 1. I can't remember, last time, did we get a 2? Did one come out with 2 possibilities? Okay. All right. Now, here's what makes things a little crazy. I mean, these word problems don't necessarily say how many triangles are possible. So you have to remember that when you set up your problem, these word problems, you set them up, if you come up with something that looks like this, so that you're gonna have to do second sign, that's your alert that, oh my gosh, I have to check to see maybe there's 2 possible answers. Okay, guys, that's when we check. All right, let's move on, let's do our word problems and see what we've got. Okay, I copied this out of your book. Some of the lines don't show up very well, but you see better than I do, so I'm sure you see what's going on. I got a triangle. This is 56. This is CA. BAC is 72. And ABC is 53. Find the distance between C and A, so I'll call that X. Okay, what do you think? Is that okay? All right, so how am I gonna find X? Find angle C, okay, what's angle C? 55. Remember the angles of a triangle add up to 180. And then see this right here? That's joy, because sine 55 over 56 equals sine 53 over X. Am I gonna have to worry about 2 triangles here? No. Nope, I got all my angles. So I'm good to go. So what's X? Let's figure it out. Did you come up with 54.60 miles? Or feet? What is my name? Feet? Miles would be kind of big. Sabrina?
So for we know it's one triangle because all the angles fit in, but for the other ones, why is there a possibility?
Because when you solve the law of sines, you are saying, find the angle whose sine is this number. Okay. And that can happen in quadrant 1 or 2. Right?
But if 2 angles are already filled in, then there's only 1.
Done. No ambiguity. Right? Okay, everybody good with that? 54.6? Second part of the question. Find the distance between the 2 canyon rims. So this is another canyon rim over here. So here's one, and here's one. So the orange are the canyon rims. And I wanna find the distance between them. What's your thought on that? I need to find the altitude, I need a perpendicular, right? So could I draw this perpendicular right here, and would that represent the distance between those two orange lines? Yep. All right, so let's talk about that for a second.
53, 90, and question. Yeah. Was he just solving for that? Right.
Let me make this, that 72 was up here. Let's look at the tiny little triangle at the top. Could I say sine 90 over 54.6 equals sine 72 over y? Look at that little triangle up there at the top. I know that's 72, that's 90. I could find this one down here, I don't need it, but I could certainly find that one. But can't I say sine 90 over 54.6 equals sine 72 over y? Look at that picture, can I say that? Now, because that's a right triangle, I could also SOHCAHTOA it. I could use SOHCAHTOA up here and say something like sine 72 equals y over 54.6. That will work out fine. Sine of 90 is just 1, so it's kind of, makes everything work out well. All right, let's go ahead. And since this was the last thing I typed in on my calculator, what if I just used my answer button times sine 72 and divided that by sine 90, which is just 1. And that way I don't have any round off there. 51.93. So instead of typing in the 54.6, I just used what was on my calculator to keep my accuracy as much as I could. Lucy?
I'm confused on how the sine of 90 goes over 54.6. Is that
This-
90-degree angle and the 72-degree angle? Is that a different triangle you just made? Like,
Lucy, that's a straight line.
yeah.
If that's 90, that's 90?
Yeah. I meant like that x value. Is that the hypotenuse of the new triangle? Okay.
Of this little right triangle right here.
Did you have to drop the perpendicular? Like, did you have to? Is that just for visual? You could have just.
No, the perpendicular is the answer to the question. When we say how far apart are perpendicular lines, it's the perpendicular running between them. So yeah, you do.
I'm confused because I thought sine 90 was just 1.
It is.
Oh, okay.
So if you did SOHCAHTOA, you'd say sine 72 equals y over x. I'm just gonna use x, okay? So if I do this, I've got 1 over x equals sine 72 over y. Those are the same equation.
Okay, yeah.
If you multiply this x over them, those are the same.
Alright.
So anytime you have a right triangle, you can go back to SOHCAHTOA. You can also use the law of sines. It works at every triangle, okay? All right, next. What's going on here? Man, there's a lot going on here. Let's see.
It's really big.
Yeah, like how much?
Geez, there's a lot going on in that picture. Alright, so we got a vertical flagpole standing beside a road, slopes at an angle of 15, angle of elevation of the sun 62, flagpole casts a 60-foot shadow. Find the height of the flagpole. So we are finding A. A is the flagpole. Alright,
Could we find angle A?
sure we can. We have a triangle, right? So 105 and 28, that's gonna make what? 47 down here. Alright, got it. Well, I think that's easy, right? Sine 47 over A equals sine 28 over 16. That seems pretty easy. I think what would make it hard is if the picture weren't drawn for us, that might make it a little harder. But now it's easy. So what do we get?
24.93.
Okay, fast. 24.93, is that what you said?
Yeah.
Sammy, is that what you got?
Yeah.
Alright, good. Okay, last one, no picture, we're on our own. Here we go. First ranger at Ranger Station A sights a fire in the direction 32 degrees east of north. Alright, so here's Fire Station A. 32 degrees east of north would look like this. Your north is straight up, 32 degrees to the east. Here's the fire. The other ranger is 10 miles due east of A. So he's over here, 10 miles due east of A. He's at Ranger Station B. Sights the same fire 48 degrees west of north. Find the distance from each ranger station to the fire. So we are looking for X and Y.
Did you solve the angle D? 48 minus 90, yeah.
You can do that, so that would be what?
42.
2. And this guy would probably gonna do this one over here.
Yeah.
That one would be 58.
And then 80.
So then we know this guy up here has to be 80. Oh, this is easy. There's no fun here. Sine 80 over 10 equals sine 58 over y. Or we could do 42 over x. We have to do them both. I don't know if you guys remember or not, but there was a problem somewhere. I don't know if it was on a review sheet or on a, here, I don't know. But there was a balloon. Do you remember that balloon was tethered on both sides? When we did, it looked kind of like this, but when we did it before, we had to drop a perpendicular down and set up a system of equations, because we didn't have our law of sines. Now that we got the law of sines, that is a super simple problem. Thank you, Peter. And what did we get? I have not solved this yet. What did you get? 8.61. What's the unit? Oh, miles, okay. And then what was the other one? Thanks. What was the other one? What? 6.7. I didn't type that in. Are we in agreement, everybody? All right, that homework's due Friday. If you're a senior and you don't have it done tomorrow, feel free to email it to me before 3:20 on Friday. Our law of sines homework. We're gonna start the law of cosines, and then I wanna do a couple of old homework questions.
Yeah, are we gonna get the quizzes back?
We are gonna get it back, that's what I said. I gotta wait, I got some people who haven't taken it yet, and I wanna give everybody a chance to get them taken. I won't wait much longer, but.
Week Friday?
Well, Friday you're not here,
Yeah.
and Monday we're not here. Yeah, we just don't go to school.
And Tuesday, we're not here.
Why not?
Not this class.
All right,
You almost threw it
now,
away, like you
I
said.
want you to turn the page. We're gonna come back and do where it says law of cosines. And I want you to turn the page, and I want you to look at number 1, says solve triangle ABC. And we know angle C is 20. We know side A is 11. And we know side B is 5. So this is problem 1A. Solve the triangle. But I want you to look at it for a minute. And I want you to think about the law of sines. If we did the law of sines, you see what's gonna happen? What's gonna happen if I try to do the law of sines? There's too many variables. Because what I don't have, that I absolutely have to do the law of sines, I don't have a pair. I don't want angle side side, but I need a pair. I gotta have angle F and side F. Or angle A and side A. And if I don't have that, I can't do the law of sines. Now, the law of sines is true. It's true that sine 20 over C equals sine B over 5. That is 100% true, but it's not solvable because it's got too many variables in it. If you're gonna do the law of sines, you have gotta have this. Whether it's angle side side or not, you gotta have this, okay? If you don't, then you're not using the law of sines and you're gonna use the law of cosines. So I'm gonna derive that now. That's what's back here on the previous page. I'm gonna derive this, law of cosines. And then the good news. Between the two of them, you'll be able to do every triangle in the whole wide world. So, when you get your given information, like in this triangle right here, I'm erasing. When you get your given information, the first thing you do is check to see, do I have a pair? Do I have A and F? If you do, law of sines. If you don't, law of cosines. Okay, so you're gonna get a random generic triangle, whether it's in a word problem or just a triangle. You're gonna check for that pair. If you have it, you're gonna set up the law of sines. If you don't have it, you're gonna set up the law of cosines. Easy. All right, what's the law of cosines look like? Well, I got my random triangle here. Does everybody understand the situation? I dropped an altitude, and that has split side B into two pieces. I'll call this piece x, so this piece is b minus x. That makes sense to you? They're not necessarily equal, but they add up to b. Now, both of these are right triangles. So I'm gonna set up the Pythagorean, no. I'm gonna set up, the Pythagorean theorem for both of these triangles. So, I'm gonna have x squared plus h squared equals c squared, no doubt about that. And then over here, I'm gonna have h squared plus b minus x squared equal to a squared. Look okay? Now, what do they both have in common? H squared, so let's solve for h squared. So h squared equals c squared minus x squared. And h squared equals a squared minus b minus x squared. So, c minus x squared equals a squared minus b minus x squared. Now, is everybody following along? This pretty basic stuff. Yeah, thank you. It is squared. Thank you. Well, this is not the law of cosines. What do you think I need to do now? Foil? All right, let's foil it. Now, be careful when you foil it. Well, let me just do it. Out. Because since that foil is being subtracted, that's going to change a bunch of signs, right? So I'm running out of room here. I need my picture. So I'm going to have c squared minus x squared equal to a squared minus b squared plus 2bx minus x squared. It's still a frightful mess. But these at least go away. So I have c squared equals a squared minus b squared plus 2bx. Oh, that doesn't look too bad. Except what? What do you think, or why do you think that is not a good formula to keep? The x. Because think about the problem I erased that we started looking at. What do you know about triangles? You know their angles and their sides. We don't know this. Would you agree with that?
Yeah.
So I need to get rid of that x. I do not want to have, that formula is going to be it, but I can't have that x in there. I need it to be just a's and b's and c's. So I'm going to look at this triangle right here. Is it true that the cosine of A is x over c? Is that true? So x is c cosine A. So I'm going to take this guy right here, and I'm going to plug him in right here. So c squared equals a squared minus b squared plus 2b c cosine A. Yeah, really close. What's c cosine? Oh, yeah. Yeah. Double C. Now, I'm going to rearrange a little bit so that it looks like what you'll see in a textbook or what you'll want to memorize. I'm just going to rearrange this. This is essentially the law of cosines. But when we write it, I'm gonna move all this to this side. Okay, so this, all this is coming over, so that a squared is by itself. So I'm gonna have a squared equal to b squared plus c squared minus 2bc cosine a. So all I did was pull all this stuff over to this side so that a squared is by itself. And the reason I did that is because it makes the pattern easier for you to memorize. The law of cosines appears in different forms, different combinations of letters. There is absolutely no point in you memorizing all of this. What I want you to do is recognize the pattern. This is the law of cosines. But look, in each case, there's only one angle mentioned in the formula, right? In this one, it's angle A. And the angle that's mentioned is the side that's over here by itself. So if I had a triangle that was XYZ, if I were doing my work with angle Z, I'd have cosine Z out here, then over here would be Z squared. Now, what's all the rest of it? Well, all the rest of it is a combination of the other two sides. So it's side squared plus side squared minus 2 side, and then my cosine. So in this triangle, it would be x squared plus y squared minus 2xy cosine z. That's the pattern. That's what I want you to know. Whatever angle is in the problem, and the law of cosines will use one angle. Law of sines uses two. Law of cosines will be one angle. That's the side that's over here by itself. Okay, and then all the rest of it in the middle is a combination of the other two sides. Side squared plus side squared minus 2 side. Okay, so let's go back to that first problem. You guys in physics, this is used a lot actually in physics. Have you used law of cosines?
No.
Not yet?
We're not there yet. Maybe AP classes. Well, we could have those.
All right, so let's go back to this first problem.
No.
And it looks like this. We agreed law of sines ain't gonna work. We do not have a pair. So we're gonna do the law of cosines. The angle that we know is angle C. Here's side C over here. So when I write out my law of cosines, I'm gonna have C squared over here, and then at the end here, I'm gonna have cosine 20. Are you remembering that, what we just talked about? Then what's gonna go in the middle here? 5 squared plus 11 squared minus 2, that 2 is part of the formula. 2, 5, 11, and that's it. That's your law of cosines, that's all there is to it. So you just type it in. The only caution I have for you about this, it's pretty straightforward. Remember when you get it all typed in, that actually is C squared. So when you get it all typed in, you're gonna have to take the square root of that. And I got 6.53. I got 6.53. Anybody else get that?
Yeah.
Okay, everybody still with me? All right, but our directions were to solve. We're not done with this problem. We still need to find these two angles. But, ready for the good news? What have we got now? Now we got what we need to do the law of sines. Here we go. Sine 20 over 6.53 equals sine B over 5. Would you agree with that? Nice, would you agree with that? So, here we go. Oh, wait a minute, what am I gonna have to do? Actually, let's talk about that. I love it, I love it. First of all, let's just type this in. Find angle B. Find angle B. So second sine 5 sine 20 divided by, I'm just gonna use second answer, I still have it on my calculator. Second sine 5 sine 20 divided by. Did you get 15.18 approximately? All right, now we can find angle A. That was B, yeah. Now we can find angle A, right? I heard somebody say we gotta draw a second triangle. Actually, we don't, because this was not the first step of the problem. This was the second step, right? I want you to look at the given. What was given? This, and this, and this. That is side, angle, side. Are there problems with side, angle, side? No. Law of sines, step 1, finding an angle is trouble, because that means you've got angle side, side. But if you've got anything else that's a congruence postulate, side, angle, side, 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 you don't have to worry about more than one triangle. Please do not worry about more than one triangle. Okay, what's my last angle then? 144.82. Now that's a huge angle. Does it make sense that that angle would be big? Yeah, it makes a lot of sense, because these guys are so small, right? These two are so small, and look at their sides. Their sides are small compared to that one. So we've got a big obtuse triangle here. All right, one more. Letter B. Oh my goodness. In geometry language, we've got side, side, side here. One answer, don't worry about anything, only one answer. Is it gonna be a law of sines problem? We're gonna need the law of cosines. Doesn't matter which one we start with, but I'll just give you a hint. One of my favorite test questions is, if I don't want you to do the whole thing, I'll say something like, find the longest side. So which side is the longest? I mean, find the biggest angle. Oh crap, I gave it away. I want you to find the biggest angle. The biggest angle is going to be the one across from the longest side. So if I said find the smallest angle, you would find side C, right? But find angle C. We're going to do A. So what's it gonna look like when I set up the law of cosines to find angle A? 9 squared equals, and then out here on the end is gonna be cosine A. And then what's gonna be in the middle here? 5 squared plus 7 squared, either order, that doesn't matter. 5 squared plus 7 squared minus 2, 5 times 7 times cosine A. Yeah,
Could you have chosen any of the sides to be?
you could, but I said find the biggest. I said find the biggest angle. And the biggest angle is gonna be across from the biggest side. So, could I find any angle? Absolutely 100%. But I don't wanna do the same problem 3 times, so I'm only gonna find one. Got it, William? You okay with that? Did he say yes?
Yeah.
Okay. All right. Now, we're gonna solve this. And I want you to be careful, because what I don't want you to do is type all of this in. You can't do that. Can you type 25 plus 49? Is that okay? Can I make that a, what is that, 74? That's perfectly okay. But don't be combining it with this 70 cosine A, because that 70 is cosine A. So 81 equals 74 minus 70 cosine A. Biggest mistake, kids want to type this in and they'll say 4 cosine A. Wrong. These can be added, those can be multiplied, but you can't combine those two. What are you gonna do instead? Subtract 74. So 7 equals negative 70 cosine A. And then divide. So 7 over negative 70 equals cosine A. Please don't type that decimal. We don't care about that decimal. We need the angle. And how are we gonna find the angle? Second cosine negative 7 divided by 70. Did you get 95.74?
Yeah.
Now, to Liam's point, could we now do exactly the same thing and find angle C? Yes. We could also do the law of sines, whatever flips your switch. Either with the law of cosines or with the law of sines, you are going to find another angle. And then once you find that angle, you can just subtract from 180 to find the last one, right? Okay, I'll leave that for you to finish. I want to look at some homework questions, maybe 1 or 2. So, I handed back some homework. I handed back every homework that I have. So, tell me what homework and what problem you need to look at. Figure out what it is. Done. 5, 4, 1C. I like the wind, but yes. So, I'm gonna split, I have to split 3x, I do not have a formula for 3x. So I'm gonna split that up into 2x plus x. And then I will use my sine angle plus angle formula. So that's sine of the first, cosine of the second, plus cosine of the first, sine of the second. That's right off your sheet. That is the formula for the sine of 2 things added together. Okay? Now, I've got to deal with these guys. This one I don't have a choice. That one is 2 sine cosine. but it's times another cosine, so I'm gonna go ahead and make that squared. And then that one, I think I'm gonna change, when I see this cosine squared here, I think I'm gonna change that into 2 cosine squared minus 1. This is one of the formulas that has different options. I'm just gonna use that option. Hopefully something good happens. So I have sine plus 2 sine cosine squared plus 2 cosine squared sine minus sine when I distribute here. Well, that did work out nicely because these two are going to cancel. And these two actually add together. So I have 4 sine cosine squared. Now, that's a product. When things multiply and give you 0, that means one of them has to be 0. So either 4 sine equals 0, or cosine squared equals 0. So where does sine equal 0? And where does cosine equal 0? That's basically the question. So I'm going to look at my circle. Sine equals 0 there and there, so 0 and pi. Cosine equals 0 there and there. So there's the answer to the question.
Oh, wait.
All right? I didn't take as long as I thought. One more, quickly, one more. Yes, Mary. 5, 4, 2a says find the tangent of 195. Well, there's more than one way to do the tangent of 195. The first thing that pops into my head is 45 plus 150. That will make 195. That's one option. There are lots of options. Formula says tan 45 plus tan 150. Oh, I can't do that. All right, then I don't have an option. It's gonna have to be tan 390 over 2. Is that 195? So that, actually I have lots, I'll just use this one. There's lots of options for tangent half angle. There's choices you can have for that one. 1 minus cosine 390. 1 plus cosine 390. So this would be one option. 390 is the same as 30, right? So the cosine, the cosine is root 3 over 2. All right, Neela, you watching here? So I'm going to multiply everything by 2 because that's just a big mess. And because these are conjugates, that actually will reduce quite nicely. If you think about it for a second, suppose I multiply, you guys hang on, you're going to love it. Suppose I multiply top and bottom by 2 minus root 3. If you FOIL the bottom, you just get 1. Wait, don't go anywhere. But the top is 2 minus root 3 squared. So what happens when I square root that? 2 minus root 3. So it's 2 minus root 3. All right, I'll see you tomorrow. for more fun and excitement. Homework due Friday for 5.5. You're welcome. Have a wonderful day.